I had great aspirations for having a longer and better video, but oh well, technology, doing this the crappy way. So this is a plotter, which is in and of itself not too unique. It's a CoreXY system that I designed and 3D printed all of the blue and gray plastic pieces in Fusion. And what's unique about this is I am using CANbus stepper motors. Now, a few of you that I've talked to know I've been trying to get these to work for a while. And basically, they are NEMA 17 motors. They are not driven by step and direction signals. They are driven by CANbus data packets. And CANbus is the same system that the cars use nowadays for all of the sensors and motors and such to talk to each other. So it's relatively complicated to figure out, especially for a new person like myself, and also because the vendor manual has a lot of mistakes in it. They have assured me they will forward my comments to their documentation department. So let's hope that gets fixed. Anyway, the way this works is that I have a Arduino Mega 2560 tucked back here, and it's pretending to 3D print something. So I'm generating step and direction signals from that board. I'm sending those signals. I've got two pairs here. I'm sending, let's say, the X step and direction signals to this Arduino Nano. That is doing two things. It's keeping track of the number of steps and directions, and it is comparing it to a encoder that is inside this motor. It's a 512 line encoder, which means I've got 2048 discrete steps or counts that I can generate per revolution of the motor. So that basically means I'm running about 1/10 microstepping right now. I'm not good at math. I'm not going to try to explain it any better. But this Arduino Nano takes the encoder position, compares it to the, come on brain, the count from the step in the direction, and basically generates a CANbus communication packet that tells the motor to move in the right direction and amount to create or reduce that error to 0. So the motor is always following the step count from the Mega board. I'm using SPI to communicate from the Nano to this MPC 2560 CANbus driver. So that's the first time I've worked with SPI, but it's working. So I've got two pairs of that, one for X, one for Y. Z, I'm just running off of a normal A4988 stepper driver, running this little geared stepper up here and running my Z up and down. I've got a linear bearing for the Z assembly, and also the pin itself floats. It's got another sliding bearing, so when the Z drops down, it drops down a little farther than needed, and then the pen tip just floats on the paper. So it's just the weight of the pen that holds it down. So that was all designed and built by me. What else? I'm trying to think of all the things I wanted to say. But the hardest part of this, building a plotter in and of itself is not terribly difficult. I'm just using, what is this, Maker Beam 15 millimeter extrusions I got as a kit a few years ago. Love this stuff, highly recommend it. But the hardest part was learning how to code well enough to take the step and direction and the encoder and all of that information, how to read everything through the serial CANbus network and then write back to it so that it could then respond in a quasi-step direction fashion. Shout out to Mike Miller, friend of mine from Mexico, who I could not have done this without his help. His encouragement and suggestions were, I just owe him a lot, so thank you, Mike, for that. What else is going on here? So one of the things I love about working with these these motors now that I can use them. So I'm going to send this home, and there's my cat. Not my cat, a cat. What I'm going to do is try to deservo or cause a step failure here. Let me pull up a different picture and print that. So what I want to do is print a single line, the edge of the image here, which it'll do in a second. And because it's a servo system basically, that it's driven by the encoder count, so it doesn't matter how badly I mess it up, or mess up the position, the encoder is always going to bring it back to where it needs to be. So I am going to pause this, send it home, and then restart it, and I'm going to deservo it. It's going to drop the pen a little bit sooner because it takes a while for the code to catch up. These nanos aren't very fast. I'm not a coder either, so my code's probably not very good. I could use some optimizing. But here's the point, is that even though I deservoed that, my pen is going the same, over the same line that it did before. If this was a 3D printer and it misstepped, it would just, end up going to the right place and continue printing. So I'm really enjoying the fact that I can completely mess with this, and it will eventually pick back up again and go back where it's supposed to go. So that's been fun for me. This system, I've tested this on the larger NEMA 34 motors I have, and everything transfers over. They all work the same. I need a bigger power supply, but that's it. But this whole system would make, obviously a good plotter. It could work with a laser, possibly a 3D printer if you wanted to print really slow. Maybe someday I'll try that. But the game plan is to use the big 34s to create a large CNC. I've got larger linear rails. I want to make a large platform CNC in the garage. So that is the game plan. That's the whole reason that I have spent months. It's literally been over 3 years since I first held one of these CANbus motors. And it was in June of this year that I really got serious about trying to make them work. And it's been months of learning how to program, learning CANbus, learning SPI, learning the CoreXY system. This is my first CoreXY build, which I've always wanted to do, so now I can knock that off my list. I learned a lot, and I'm bragging a little bit because I feel like I deserve to. This was a real brain stretcher for me. Been fighting some brain issues, and I can feel myself slowing down, and I'm kicking and screaming the whole way. I refuse to just drop off without giving a fight. So this is my way of engaging my brain and keeping myself sane at the same time, because I love doing this kind of thing. And you can see the results are good. They're great. I think this is going to make a great platform for CNC. So thanks everyone. Thanks for being a part of this little journey. Sorry it took so long for an update. I have issues. Kitty!